Day 733 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we got question number 1861, rotating the box. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an n by n matrix of characters box grid representing a side view of a box. Each cell of the box is one of the following. A stone is a pound sign, a stationary obstacle is asterisk, and an empty is a period. The box is rotated 90 degrees clockwise, causing some of the stones to fall due to gravity. Each stone falls down until it lands on an obstacle, another stone, or the bottom of the box. Gravity does not affect the obstacle's positions, and the inertia from the box's rotation does not affect the stone's horizontal position. It is guaranteed that each stone in box grid rests on an obstacle. Another stone it is guaranteed that each stone in box grid rests on an obstacle, another stone, or the bottom of the box. Return an n by m matrix representing the box after the rotation described above. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input box grid equals a 2D array of strings, pound sign, period, pound sign. The output is a 2D array of strings, period, pound sign, pound sign. So, let's take a look at this picture so we can see how we got this output from this input. So, as you can see, if we turn this right here by 90 degrees, all of these, what do they call it? Stones, all of these stones will fall to the bottom like they did here, right? Right now, they're all at the bottom because it's resting horizontally. If we turn this vertically, then the stones will still fall to the bottom because of gravity. It says right here, causing some stones to fall due to gravity. So this is just representing how the stones fall after the gravity. Boom. So let's take a look at example 2. So in example 2, we have an input box grid equals a 2D array of strings, pound sign, period, asterisk, period, pound sign, asterisk, period, right? And remember, each one of these strings represents something different. So the pound sign is a stone, the asterisk is a stationary obstacle, and the period means it's empty. So boom. So this right here, as you can see in our visual representation, is the obstacle represented by the asterisk, right? Boom. So once we turn it like this, once this is horizontal, once we turn it vertically, as you can see, this stone is going to fall to the bottom, but it's going to be stopped here by this obstacle. So the stone will fall from here, it'll flip, it'll fall from here to the obstacle and rest at the bottom of the obstacle, or at the top of the obstacle like this. And then in the end, our output will be pound sign, period, a 2D array of strings, pound sign, period, pound sign, asterisk, asterisk, period, period. And that's what it looks like here. Boom. So let's take a look at example 3. In example 3, I'm not going to go through the whole input of pound signs, periods, and asterisks. You can see them right here. But as you can see, same principles apply. When we turn this vertical, boom, everything right here in this row, since there's no obstacle in this row, everything right here is going to fall. Boom. These are going to remain stationary. They're not going to fall because they have an obstacle blocking these from falling. These right here won't fall because of this obstacle, and these right here won't fall because of this obstacle right here. And it says right here, somewhere up here, it talks about how the inertia does not affect the position of how, right here, the inertia from the box's rotation does not affect the stone's horizontal position. So we don't have to worry about stones slipping and sliding as we turn it from here. We know that this is going to stop these stones, and this is going to stop these stones. Boom, y'all. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, First thing we're going to do is we're going to get the number of rows and columns in the original box. So we're going to say let rows equal box grid dot count. Boom. Then we're going to say let calls equal box grid square bracket 0 dot count. Boom. Now we're going to create the result matrix with dimensions flipped and fill initially with a period or an empty space. So we're just going to create a default to the array for our output by declaring a variable called res. We'll set that equal to an array. Open up the parentheses. We're going to say repeating colon. It's going to be another array. Open up the parentheses. It's going to be repeating colon character. Open up the parentheses, quotation marks, period. Come outside of that. We're going to say comma count colon rows. Then we're going to come outside of that. We're going to say comma count colon calls. Boom. Then we're going to iterate through each row of the original box. So we're going to come underneath this and we're going to say for r and 0 dot dot less than rows. We're going to open up the brackets and we're going to create a pointer that tracks the rightmost available position where a stone or a pound sign, sorry about that, can fall due to gravity. So we're going to declare a variable called I and set that equal to calls minus 1. Boom. Then we're going to traverse the row from right to left. So we're going to say for C in stride, open up the parentheses, from colon calls minus 1 comma through colon 0 comma by colon negative 1. We're going to come outside of that. We're going to open up the brackets, and if we encounter a stone, we check that by saying if box grid. Hold on, y'all. Sorry. Hold on, y'all. So if box grid square bracket R square bracket C equals, open up the quotation marks passing a pound, come outside of that, we're going to open up the brackets and we're going to place it at the lowest available position after rotation. So we're going to say res square bracket I, come outside of that, square bracket rows minus R minus 1, come outside of that, equals pound sign. Then we're going to move the pointer left. So we'll come underneath this and we'll say I minus equals 1. Boom. Then we'll come right here, right here on the if, and we'll say else if box grid square bracket R square bracket C equals, open up the quotation marks and asterisk, then we'll open up the brackets and we'll place the obstacle in its rotated position by saying res square bracket C, come outside of that, square bracket rows minus R minus 1, come outside of that, we'll say equals quotation marks and an asterisk, sorry, not an X, that should be an asterisk, boom. Then we need to reset the pointer to just left of the obstacle. So we are going to say, we're going to come underneath this and we are going to say I equals C minus 1. Boom. Then we need to return the rotated box with the gravity applied by coming all the way down here, and we could just say return res, y'all. Boom, that should be all she wrote. Let's give it a run. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 34 milliseconds beats 77.78% of users. That's what I like to see. So with that being said, y'all, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.